Hey guys, I'm Legare, and in this video, I'll show you how technology that's powered by large language models can go beyond conversation and actually take actions in our digital world. Imagine typing, summarize this PDF, and store the results in an S3 bucket. And having the system wire together extraction, summarization, and storage tools all behind the scenes. Now, large language models alone are basically probabilistic maps of language. They learn how a bunch of different words and ideas all relate to one another. But that only gets you so far, because if you were to ask an LLM, what is 233 divided by 7? It's going to guess based on the patterns it learned, not based on compute. So instead, for our LLM assistant to be able to give us that answer, we are going to need to call on an external calculator API. And suddenly, it can now perform real math. So now if we scale that idea, your LLM-powered assistant can call any microservice, a database, a cloud storage API, a document summarizer, just by understanding that your intent in natural language requires a tool. So in this video, we'll break down the architecture of a tool orchestrator, which is the system that lets an LLM call an API safely and reliably. We'll cover how to do this in 4 steps. The first being detecting that a tool call is required. The second being generating a structured function call. And then the third, going to be executing those calls in isolation. And then finally, reinserting that result back into the conversation. First, the model must recognize that a user's request requires external action. To make a model understand this, it needs to be fine-tuned on synthetic examples where semantic cues, words like calculate, translate, fetch, or upload, signal that a tool should be used. This can be reinforced through few-shot prompting or taxonomy-based data generation. Once the model has detected that a tool is needed, it then must generate a structured function call. And this is going to occur via calling on a function registry. Now, this function registry is something you can think of like a phone book that stores what tools exist and the metadata that they require, like their endpoint URL, their auth method, their input and output schemas, their execution context, etc., etc. This register layer can be implemented via a YAML or JSON manifest file checked into Git, a microservice catalog, or a Kubernetes custom resource that's describing these callable functions. And then from there, the LLM will use this function registry to generate a schema that matches the chosen tool's needs. Now we're going to need to trigger this execution layer here. The function call that we are going to hand off to the execution layer is going to execute in a runtime environment that will perform this operation. Each tool will run inside of an isolated container for safety. You can think Podman, Docker, or Kubernetes jobs here. And this is going to allow for retries, error handling, and scaling across different tool types without exposing the model directly to the internet. And then finally, the tool's response is going to be serialized and fed back into the LLM as context for the system message. So the assistant can reason about the result as a part of the conversation. This is known as return injection. And it's how the model can say that the answer to 233 divided by 7 is 33.29, or summarize your document, or confirm an upload without breaking the conversation flow. And that's how a language model goes from predicting words to executing actions using tool orchestration.